We have one question from the chapter application of derivative based on maxima minima. The question says that the sum of the perimeter of a circle and a square together, right, is given as k. Well, k is a constant, has to be. Now we have to prove that the sum of their areas, that means their sum together, is least. That means we need to minimize the least and prove that the area is least when when the side of the square is double the radius. So this is what we need to prove here. Well, you should be aware of the flow chart here that first using fx, we find f dash x, then we equate f dash x with 0. That gives the different extremes of x, maybe the critical point we call as x1 and x2. Then we find f double dash x and check the sign of f double dash x at these critical point, that is x1 and x2. If f double dash, say at x1, if it is greater, we say it's the x1 is the point of local minima. And if it is less than 0, that is negative, we say it's a point of local minima, right? Now, to begin with the question, let's write down the information. First, we are given a circle. Let's say I made a circle, and then I need to make a square. I made a square over here, and that's fine. And let's write down the dimension here, what we know as the radius of this. Let's say I mark this radius as, say, r. I mark the radius as r. I took this side as x. So we got these two figure, and if I find their perimeter, which is in case of a circle is nothing but its circumference, and in case of a square it is 4 times x. According to the question, it is given that sum of these two is k. So this is the information given where k is a constant. That has to be kept in mind. Then we will begin with the to prove is what? To prove is what? We have to prove that the side of the square is what? X is equal to double the radius. So this is something which we have to prove. That have to keep in mind. Now we'll always begin with the one which we have to differentiate or minimize or maximize. Since we have to minimize the sum of the areas, we will begin with the area formula. For a circle, it is pi r square, and that of a square, it is x square. Now, before we proceed the differentiation, we need to do substitution because here are two variables. One is r and other is x. Now, what I'm going to do, I'm going to extract x from here. So if I do so, it will be what? K minus 2 pi r over 4. This is what we will do. I'm going to replace this x square here. Now, let's say this a be a only. This is pi r square. And then x square can be written as k minus, from the equation we have x square is k minus 2 pi r over 4 whole square. Now, if I simplify it, I can say this is 4, this is pi r square. So this is pi r square as it is, and this is k minus 2 pi r square over 16. So I can take LCM and write 16 as whole. That's okay if I write like this only. Now it's in one variable. Now I'm going to find its derivative. So clearly we'll be differentiating here with respect to x. So dA by dr, differentiation of this is what? 2 pi r. Here 16 is coefficient. So differentiation of this will be what? This is 2 times k minus 2 pi r. And by chain rule, this is 2 pi r. And by chain rule, we are going to get minus 2 pi from here. So I'll write minus 2 pi, that over 16 being a constant. Now further I can see we can reduce something here, that is with 2. Yeah, this is going to be 4, right? 2 2s are 4. So if I further write in simplest form, it's going to be, we can take LCM. If I take LCM, this will become 8 pi r. And I can see there is a minus sign over here. So that will make it minus. Pi is outside, and this is k minus 2 pi r over 4. Now we know that we have to before we have to find, we have to do double derivative test also. So why not find the double derivative here only? So if we find double derivative d square a by dr square, the derivative of this is going to be 8 pi minus pi being coefficient here. The differentiation of this will come as, this is minus of minus 2 pi, because the derivative of r is 1, right? So it's minus 2 pi. So that will make it plus 2 pi over 8. As we can see here that all of them are, this is 4 here. This is constant, so has to be greater than 0, irrespective whatever is the value of x and r. Now, once we have done this till here, now we are going to apply, we are going to equate f dash x, right? We are going to equate dA by dx with 0 so as to get the critical point, right? 4 lost, so write 4 here. Now, as I said, we have to, in order to find the critical point, we need to equate dA by dx with, or dA by dr in this case, with 0. I'm going to equate this with 0. So this is 8 pi r minus, I can take pi common here. That will make it easier. So that if I take pi as common, we are going to get, and the 4 in the denominator is also there from here, right? From here. So this is, we'll get here as 8r minus k, and I'm simultaneously opening the bracket here, or let's keep it only, minus 2 pi r should be equated with 0. So this is on the other side will be 0. So what we are getting, 8r, on transposing this whole thing to the other side, we'll get k minus 2 pi r. And if I isolate k, I'm getting, this is 8r plus 2 pi r. Now what next? We are going to plug in k over here so that we get the relation between r and h. So this is what we have already obtained. Let's bring it here. We can see that we have these k as equal here, same k here. So we can equate these two equations and obtain the relation. So I can see in that case, it will be 2 pi r plus 4x should be equal to 8 times from here. 8 times r plus 2 pi r. Further, this 2 pi r get cancelled. 2 pi r and 2 pi r get cancelled. So on transposing, we are getting, cancelling this with 8, we are getting 2r. X is equal to 2r. And we'll say therefore, hence. And we need to show also that this is greater, double derivative is greater than 0 at x is equal to 2r. Although it is independent of r, for any value of x, it should be greater. So we'll say hence maxima at this point. And I can see this is what we need to prove, that x is equal to 2r.